Hi, this is Mr. Lyons. In this last video for section 10.2, we're going to analyze parabolas with the vertex at h and k now instead of the origin. And then also we're going to take a look at an applied problem involving parabolas. So here we have our right-facing and left-facing parabolas, which means that we're going to have y-squared equation. This time, though, h and k are not 0 and 0, so we have to subtract our k from the y in the equation and our h from the x in the equation, where h and k are the x and y coordinates of the vertex. This is what's commonly known as vertex form of the parabola. Same thing for up-facing and down-facing parabolas, except now it's an x-squared equation as before. We have our vertex hk. We've got to subtract those from the x and the y in the vertex form of the equation of a parabola. So let's illustrate this new form of the equation with h and k in it by looking at this example. It says find an equation of a parabola with a vertex at 5, -1 and a focus at 2, -1. Graph the equation. Okay, so first we're going to put these points on the graph here. So let's get going on that. Our vertex is at 5, -1. 1, 2, 3, 4, 5, -1. Right there. Our focus is at 2, -1 right here. So that means we're going to have a left-facing parabola. So we can put down our form of the equation now that includes h and k. It's a y-squared equation because it's facing left. So we have our y-squared. But I already forgot, I got to put in my k. So y minus k squared is what we need to start with. That's equal to 4a times x minus h. And since the parabola is left facing, we need to have a negative in front of the 4a. We can see here that our a is equal to 3, and so that means our directrix is going to be the other direction from the vertex, 3, so we're going to go 3 this way, and therefore our directrix is at x equals 8. So let's set up our equation here so that we have our vertex in there and our a. So our k is the y-coordinate of the vertex, which is a -1, which is going to make this y plus 1 squared. We're going to plug in our 3 for a. And we're going to put in our h, which is the x-coordinate of the vertex, which is a +5. Let's go ahead and simplify this. So we have a -12 here times x minus 5. There's the equation of our parabola. So we need to graph our parabola now. We need some more points on it. So we can set up the latus rectum again here, which is going to be where the focus is here. And so remember the latus rectum, the distance from the focus is plus or minus 2a to those points on the parabola that coincide with the latus rectum. So we're going to go ahead and just plug in our 3 for a, so we have plus or minus 6. So we're going to count 6 each way to the parabola here. So 6 up. 1, 2, 3, 4, 5, 6 right here. Make it so we can see that point. There it is. And then 6 down. 1, 2, 3, 4, 5, 6 down from the focus. Go ahead and draw a parabola through those points. There's our graph. So again, here's our equation. We have our directrix, we have our focus, we have our vertex, and we have the graph of the parabola. We can also graph parabolas on our calculator, as you know. We'd have to solve this equation for y, which means we're going to end up with a positive root and a negative root. We'd put that in y1 and y2 in our calculator. I'll leave that for you to do. I do want to analyze this equation with you. So notice this is in standard form. We need to put it into vertex form, which means that we're going to have to complete the square. I think you've seen this before. So we've got to get our y terms together here. Y squared plus 4y. B over 2 is going to be 2. Squared is 4. So we're going to add 4 here to complete the square. We're going to move our 4x over to the other side, our negative 4x, I should say. Since we added 4 to the left, we need to add 4 to the right. And so let's get this in our vertex form here. We're going to have our y plus b over 2, which is 2 squared. That's equal to our... Now we need to have the coefficient of x be 1, so we're going to factor out a 4 here. So it's going to be x plus 1 here for that factor. So there's the equation of our parabola, which means our vertex is going to be at negative 1 for h and negative 2 for k, isn't it? Let's go ahead and plot that. Okay. And then we need to find our focus. That means we need a, so we're going to go ahead and take the multiplier of x over there, which is 4. We're going to set that equal to 4a. So 4a, 4a has to be equal to 4. Therefore, a is equal to 1. Go ahead and plot that. We're going to have a right-facing parabola, aren't we? So the focus is going to be to the right. Again, the reason it's a right-facing parabola is because the sign is positive in front of the 4a multiplier. So we're going to have 1 to the right here is our focus, and then 1 to the left from the vertex is going to be our directrix. Let's draw that in. And that's at x equals negative 2. We need some more points on the parabola, so we're going to set that up with our lattice rectum again. So therefore plus or minus 2a is going to be plus or minus 2, because a is equal to 1. So we're going to go 2 up from the focus to get to the parabola on the lattice rectum. going to be at the origin, and then 2 down from the focus, which is going to be here on the y-axis. Okay, so we're going to go ahead and draw our parabola. So we have all of the features that we need to have for analyzing that equation of a parabola. Let's take a look at an applied problem here. So a couple of examples of applications of paraboloids, they're called, where we take a parabola and rotate it around its axis of symmetry. For instance, a searchlight here, we have a light source at the focus. It's shining at the surface of the inside surface of the paraboloid, and then that projects the light out. And then here the telescope, we actually have the light coming into the telescope, bouncing off a parabolic lens, and then that focuses it to a focus point up here that would be observed. Okay, so let's take a look at this example. We have a satellite dish, which is a paraboloid. The singles that it is going to receive are coming from a satellite, obviously. If the dish is 10 feet across at the opening and 3 feet deep at its center, at what position should we put the receiver? Well, certainly the receiver needs to go at the focus point, doesn't it? So we need to find the focus for this particular paraboloid. We don't need to actually keep it in that orientation at some odd angle there. I'm going to actually make it right facing here on a graph with the particulars, the 3 and the 10 feet here. So let's put the vertex at the origin. That's easy to work with. And then we have 3 feet by 5 feet up and 5 feet down. So the points on the parabola are going to be 3, positive 5. Let's plot that. And we're going to have a point at 3, negative 5. So let's go ahead and draw that parabola, or graph it, I should say. We know that it's a right-facing parabola with vertex at the origin, so we're going to start with the equation y squared is equal to 4ax. We're going to plug in one of these points. Let's use the positive coordinates 3, 5. So 5 squared for, put 5 in for y. And then 4 times a times our x of 3. And so we're going to be able to find a this way. So we have our 25 divided by 12 is equal to a. And therefore we can plot the focus at 2 feet and 1/12 of a foot, which is an inch, right? So a is actually equal to 2 feet 1 inch, isn't it? Okay. And so plotted on here, we have units of feet on the x-axis, so we're going to go ahead and just go a little bit over 2 here with a point. And that is where we need to put our receiver, isn't it? And again, you know, we could describe that with words. We could say that the focus will be on the axis of symmetry at 2 foot 1 inch from the vertex. Okay, well, that's the end of this video. I hope it helps. See you next time.